Hi friends, welcome to Acharya Gurukulam. Today's topic is logistic regression analysis. In this video, I am going to discuss what is logistic regression analysis, the mathematical background, performance metrics. At the end of this video, I am going to solve a problem. What is logistic regression analysis? Logistic regression analysis is a classification algorithm used to predict binary outcomes for a set of independent variables. The dependent variable outcomes is discrete. A plot is drawn between a dependent variable x and dependent variable y. The outcomes are y is equal to 0 and y is equal to 1. To decide the outcomes y is equal to 0 or y is equal to 1, we need a threshold value. Generally, the threshold value is equal to 0.5. The equation p of x is equal to 1 divided by 1 plus e to the power of minus beta naught plus beta 1 x, which is also called as a sigmoid function. The logistic regression is classified as three categories. One is binary logistic regression. It is used when the response is binary. For example, 0 or 1, pass or fail, high or low. Nominal logistic regression. It is used when there are three or more categories with no natural ordering to the levels. For example, black, red, blue, pink, etc. Ordinal logistic regression. It is used when there are three or more categories with natural ordering to the levels. For example, good, better, best, or slight, moderate, or severe. Coming to the mathematical background, the probability of event happening, which is P of x, and the probability of event not happening, that is 1 minus P of x, the ratio we consider as odd of theta. To predict the odds of success, log P of x divided by 1 minus P of x, which is equal to beta naught plus beta 1 x. Let's y is equal to e to the power of beta plus beta 1 x. P of x is equal to y into 1 minus P of x. After simplification, we obtain P of x is equal to e to the power of beta naught plus beta 1 x divided by 1 plus e to the power of beta naught plus beta 1 x. Of further simplification, the equation P of x is equal to 1 divided by 1 plus e to the power of minus beta naught plus beta 1 x. For P of x, if P of x is equal to 0, the odd of theta is equal to 0. If P of x is equal to 1, then odd of theta is equal to infinity. The coefficients in this equation, that is beta naught, beta 1, beta 2, beta 3, and so on, these coefficients are determined using maximum likelihood method or gradient descent method. The performance metrics are as follows: confusion matrix, accuracy, precision, recall, F1 score, and ROC. ROC means receiver operating characteristic curve. Before going to solve a numerical problem, we need to understand the terminology in logistic regression analysis. First one, true positive, which is denoted as TP. It means the actual label is positive. It means 1. And machine learning model is positive. It means 1. True negative, which is denoted as TN. Actual label is negative, that is 0. And machine learning model is negative, which is also 0. False positive, which is denoted FP. Actual label is negative and machine learning model is positive. False negative, which is denoted as FN. Actual label is positive and machine learning model is negative. Let us solve a numerical problem. In this example problem, I consider 20 values having x1, x2. So based on x1, x2, it is classified as 0 and 1. The yellow color indicates the input values and light green color indicates the output values. So based on the x1 and x2 values, so substitute x1 and x2 values in the equation z is equal to minus 1.759 plus 0.706 PGA, which is x1, plus 0.352 into damage, which is x2. So P of x is equal to 1 divided by 1 plus e to the power of minus z. Let us consider one row of value. In this analysis, I consider PGA is equal to 0.83 and damage is equal to 0.42. And the coefficient values that is minus 1.759, 0.706, and 0.352. These coefficient values are obtained gradient descent method. After substituting the values, the P of x is equal to 0.264. That is 0.264. So if we set the threshold value is equal to 0.5, then the classification is 0 for P of x is equal to 0.26. Based on the machine learning classification and the classification of input data, so another column is created with the true negative, true positive, false negative, and false positive values. The accuracy is determined using an equation Tp plus Tn divided by Tp plus Tn plus Fp plus Fn. Tp is the true positive values from the analysis. The value is 9. True negative values are 8. And summation of Tp, Tn, Fp and Fn are 20. So which is equal to the number of data points in the set of data. The accuracy value is 0.85. Similarly, precision is calculated as the ratio of true positive to true positive plus false positive. The precision value is 0.9. Similarly, a recall, that is 0.81, F1 score 0.857. The confusion matrix is generated with the values true negative, false positive, false negative, and false positive. So based on the analysis, the true negative values are 8, false positive values are 1, false negative values are 2, true positive values are 9. The confusion matrix is also compared with the MATLAB, and you can see the similarity of the results obtained from the manual calculation as well as MATLAB. The ROC curve is drawn between a false positive rate versus true positive rate. The equations are as follows. True positive rate, which is equal to the ratio of true positive to true positive plus false negative. And false positive rate is defined as the ratio of false positive to false positive and true negative. So based on true positive rate and false positive rates, the ROC curve, that is receiver operating characteristic curve, is drawn for classification 0 and classification 1. And the value 0.798 is the area under the curve. The main key takeaways from this video are what is logistic regression analysis and the performance metrics corresponding to the logistic regression analysis, how we generate a confusion matrix and ROC curve. Thank you. Jai Hind.